Good morning, students, once again. See, in the previous video, I have covered the topic fundamental laws of nature, and I explained you how these fundamental laws drive our whole universe. All the things happening around us, every phenomena, even if it is in biology, chemistry, or in any other any other topic, they all are governed by these laws, right? So if you say that, sir, these law also apply in the chemistry? Yes, definitely, because the origin of the any subject is mathematics. Then after mathematics originates the physics, then physics originates the chemistry, chemistry originates the biology, and so on, right? So we can see that the mother of all these subjects is mathematics. Okay, so therefore all these laws are applicable in every field. As I told you, the symmetry of the laws, that these laws are not only applicable to this earth or our solar system or in our galaxy Milky Way. Even if you go to the other galaxy, intergalactic distances, these laws are applicable everywhere, right? Although किसी ने वहां जाके देखा नहीं है, but we assume that these laws are applicable everywhere. All right. Now today I will discuss one more very important topic of physics, which is nothing but fundamental forces. See, although we can't cover this single topic in one class, not only one class, I can say that if we talk about only one force, like we have four fundamental forces, I'm choosing the one, let's say, gravitational force. So scientists give their whole life to explain how these forces works. You know that Newton gives his very important part of life to explain the gravitation law. Then after certain time, Einstein come and say, and he said that all the things Newton said was all wrong, right? It is not how the gravitational field works. Then he gave his own theory. So basically, these all the forces, they are basically four fundamental forces. Each force have, we can say, it's a big history. We can't talk about these forces, not all these four forces. We can't cover the single force in a single day or a single month or a single year. No, we can't exactly complete them. I can just give you a gist about the introduction of forces, right? I can just give you the introduction, so that when you find any topic related to these topic fundamental forces, you can remember how these forces are work, right? So in the nature, we have so many forces. We say friction forces, drag forces, upthrust, tension, electrostatic, electromagnetic, magnetic forces, gravitational forces. There are so many forces, right? But basically these forces are examples of fundamental forces. We only have four fundamental forces in nature, and only by these four fundamental forces the complete natures run. So what are these forces? These forces are, first is gravitational force. I think you all aware of it. You have done some introduction in the class 9. We have in the I think 4th and 5th chapter we have the Newton's law. So this is the gravitational force. Then we have electromagnetic force, right? Again, electromagnetic force, you must have studied in the class 10th that this force acts between two charges, right? having positive or negative or positive. So this force is due to the charges. Then we have weak nuclear force. And the last we have strong nuclear force. I think you are not aware of these two forces. What are these forces? I'll give you a simple introduction about what are these forces, how they work, right? And G force and the EM force, you know about it. Again, I'll give you a small gist about them. So let's talk about these forces one by one. Okay. So the very first talk we'll talk about is our gravitational force. Gravitational force, the very first time Newton explained how this gravitational force works. He said that whenever we have two masses, let's say m1 and m2, and they are separated by a distance r. So due to their masses, right, see, please underline this word, masses, this force arises due to the effect of mass. Okay, so due to masses, the force of attraction between these two is directly proportional to the product of their masses, and it is inversely proportional to the square of the distance between them, right? So I think now you remembering something, that you have done this force in class 9th, right? The gravitation force. So when we combine these two laws, what we get? We get F proportional to m1 m2 upon r square, or simply F equals to G m1 m2 upon r square, right? So Newton said that each and every particle in this universe, whether it is the tiniest particle or a very, very big particle, they attract other particle with some force known as gravitational force, and that force depends upon the product of their masses. Like if the product is more, obviously force is greater, and it is inversely proportional to distance, square of distance between them. That means closer the particles are, stronger the force they will experience, right? So when we combine, and he will give this formula where G is a universal constant. You know that the value of G is nothing but it is 6.67 into 10 to the power minus 11 Newton meter square upon kg square. So this is the value of the G, universal gravitational constant. See, when we say this is a universal constant, it means if you go in the entire universe, the value of this capital G will remain same. It will not change, right? We have the complete gravitation chapter in our syllabus also. We'll study about it more thoroughly. So this is G. It is same as the Earth. It is same on the Moon, on the Mars, Saturn, and if you go to the Andromeda galaxy, it will again be the same. What is Andromeda galaxy? It is the nearest galaxy. We can say it's a neighbor galaxy to our galaxy. And one more interesting fact is, I think some of you are familiar with it, that our Milky Way galaxy and the Andromeda galaxy, they both are approaching each other. So after some millions of years, they will collide with each other, and a new galaxy will be formed. And the name, already we have given the name to that galaxy, the combination of Andromeda and the Milky Way. That is the Milkomeda galaxy, right? So after after billions of years, these both galaxies will combine each other, right? And a new Milky Way, a new galaxy will form known as Milkomeda. So I was saying that this value of G will be same everywhere. It will not change for the Earth or for the Moon or any other planet or any other galaxy, right? Now, this is the central force. Now, what is central force? Central force is basically these forces act the line joining the center of the two bodies. Like suppose we have, see here I've taken the 2 point masses, but suppose if we have two big objects like this, then this force will not act on the surface. No, this force will act to the line joining the center, right? So this is basically central force, right? This is mean the central force. Then it obeys the inverse square law. Now, what is inverse square law? There are some forces in nature which follow the inverse square law. Inverse square law means the force between them is inversely proportional to the square of distance between them. It means they follow the inverse square law. There are some more forces which follow the inverse square law, like Coulomb's law, the Biot-Savart law, right? We will study in the next chapter. So it follows the inverse square law. Now, after some time, see, there are so many phenomena which is explained by this formula, like how the moon revolve around the earth, how the planets revolve around the sun, how the sun revolve around the galactic center of our galaxy, right? So this gives the absolute correct result by when we apply the value, this law, the Newton's gravitation law. This gives the absolute correct result. But there are some problems arise in it. There are some concept, there are some, we can say, phenomena in nature happening due to gravity, though these can't be explained with the help of this Newton's gravitational force. There are some phenomena which cannot be explained with the help of the G force, like the time dilation. You must have heard about the time dilation. I don't know if some of you have seen a movie Interstellar, and if you see the movie Interstellar, you know about the time dilation, right? And with that, astronaut goes to a planet which is orbiting about a black hole. So when you go there, the times went very slow. So when he reaches to the Earth after only 2-3 years or some time, all the person on the Earth, they get old, but the hero, that the person only aged 2 to 3 years. So time dilation does not explain with the G force. Einstein came and he said that this is completely wrong. He said that this is not how the gravitational work, because Newton don't explain. Newton said that these two forces, that two masses attract each other with some force, but he did not say how. Why these two masses are attracting each other? Why the Earth is orbiting around the sun? Why the moon is orbiting around the Earth? There must be some solid reason behind it. Then comes a theory known as general theory of relativity. You must have heard this term. I'm not going into the deep. I'm just giving you a just about it. As I told you that this topic can't be covered in only 1-2 lecture, or we can say in a month lecture or in a 1 year lecture. It's a complete research on it, right? I'm just giving a gist. So Einstein said that all the heavy matter, all the heavy masses curve the space around them. Space, you know that space. Sometimes we say that what is space? That we say nothing. No, space is not nothing. Space is something which can bend, which can expand, right? Which can squeeze. So space is not nothing. When we say if we remove everything from the universe, every star, every planet, everything, what we are left with. So someone says nothing. No, we are left with space, and space have its own properties, right? So Einstein said that whenever the any massive body curve the space around them, right? So I can show you with the example. So let's say this is a massive body. Let's say this is the sun. So what it do, it band the space around it like this. Now imagine, I don't know if you played with the marble, कंचे जो होते हैं. So imagine you have, let's say, a long rubber sheet, right? You have long rubber sheet and आप चार लोग उसको चार कोने से पकड़ लो, stretch कर लो उसको. Now put a heavy ball in between that stretch sheet. What will happen? That stretch sheet will be curved like this. Can you imagine this? हमने एक रबर शीट ली है, रबर शीट के बीचों बीच में एक भारी सी बॉल रख दी है. So what will happen? It will form a curvature around it. Now take a marble and throw it here. What will happen? It will start rotating, orbiting around that heavy ball. This is the cause of gravity given by the Einstein, right? That heavy object curve, bang the space around it. Okay, so this is a theory given by the Einstein. Now so many phenomena which can't be explained with the help of the Newton's gravitational law now can be explained with the help of this theory of relativity. Okay, now again there is one more modern theory. I'm just giving you only 2-3 lines about it. There is one more modern theory. They said again there is we can say the theory of relativity is a bit incomplete. Modern theory says that if any two particles attracting or repulsing each other, that means they have some kind of interaction between them, then there are some interchange of particle between them, right? Suppose I am saying that we have two masses, this is mass m1, this is mass m2, and they are attracting each other. So modern theories say that there are some interchange, there are some interchanging of the particles. Some particle is going from here to here and some other particle going from here to here, and this happen continuously. Due to this interaction, due to this exchange of particles, the force arises. Because again, we don't have the proof how the force work, right? I'm saying that two masses attracting each other, but how? How can the two masses, which is not connected by any string or any other physical contact, and they are attracting each other? Why? We don't know about this. So the modern theory, although this theory is in the developing nature, this is developing, it is not fully developed yet. It just, we can say we are working on it. It says there is some particle exchange between these masses, and that particle is known as graviton. So actually this particle has not been discovered yet, but we have already given the name to it, that there must be some particle which is exchanging between these masses, and that is why the G force is working between two particles. So students, I have covered the gravitation force, one of the fundamental forces, gravitational force. If we talk about the magnitude, then in terms of magnitude, this is the weakest force in the universe. Now you can see that it's the weakest force. Due to this forces, we are connected to the sun with this, and the sun is connected to the galaxy. But yeah, this is the weakest force, because when I explain you the other forces, then you will understand why this force is weakest. It means that there are some forces in nature which is more stronger than this force. Even not stronger, they are far more stronger than this force. We'll cover that some forces in the next video. Thanks very much.